Hi, welcome to the tutorial on molar conversions. In this tutorial, we'll discuss several different types of problems that you may encounter and how we can solve those problems using the mole tunnel. So our first problem is a conversion where we go from moles to volume. We have a sample of methane, CH4, which occupies 4.50 liters at standard temperature and pressure. How many moles of methane are present? So I need to identify my givens and my unknown. And my given is 4.50 liters of methane, and my unknown is the number of moles. So I'm starting with a volume, and I want to find the number of moles. If we go to our mole tunnel, we can see that if we start down here with a volume, and we need to determine the number of moles, we're going to be using this conversion factor. 1 mole is equal to 22.4 liters, assuming we're at standard temperature and pressure. So now that we've identified the conversion equality we're using, we need to set up the problem. And if we look at how I set that up, I started with my given, 4.50 liters of methane, and then I set up my conversion equality, 1 mole of methane is equal to 22.4 liters of methane, with the liters of methane at the bottom so that it would cancel out. And I got my answer of 0.201 moles of methane. Let's try another. For this problem, we're going to be going from moles to molecules. You have 3 moles of carbon dioxide, CO2. How many molecules of carbon dioxide are present? So to solve this problem, I need to identify my given, 3 moles of carbon dioxide, and my unknown. I want to know how many molecules that is. So we want to know the number of molecules, and we have the number of moles. I'm starting here with moles, that's my given, and I need to go to molecules. So to do that, I'm going to be following this pathway on the tunnel, and I'll be using Avogadro's number. 6.02 times 10 to the 23rd molecules is equal to 1 mole. So as I set up this problem, I'm going to have my 3.0 moles of carbon dioxide as my given, and then I'm going to be using Avogadro's number. 1 mole of carbon dioxide is equal to 6.02 times 10 to the 23rd molecules of carbon dioxide. Note that I set it up so that moles of carbon dioxide cancels out, and my answer is going to be in molecules. And I get 1.8 molecules of carbon dioxide. For my third problem, let's demonstrate using a conversion that gets us from molecules to a volume. How many molecules of hydrogen gas, H2, occupy 0.5 liters at standard temperature and pressure? So my given is the 0.5 liters at STP, and I want to know the number of molecules. If we look at that on our mole chart, we're given a volume in liters, and we need to know the number of molecules. I can't get there directly. This is going to be a 2-step problem. I'm going to have to go from my volume in liters to moles, and then from moles to molecules. So when I set that problem up, I'm going to be starting with my 0.5 liters at STP, and I'm going to go from liters to moles using my conversion that there's always 22.4 liters of hydrogen gas and 1 mole of gas. And then I'm going to go from moles to molecules using Avogadro's number. 1 mole of hydrogen gas is equal to 6.02 times 10 to the 23rd molecules of hydrogen gas. And we can see how units are canceling out, and my answer is going to be in molecules. And I get a final answer of 1.34 times 10 to the 22nd molecules of hydrogen gas. Molar mass seems to be the sticking point for a lot of students. So before we get to that next part of the tunnel where we're converting using molar masses, let's review really quickly what that means. Molar mass is simply the weight of 6.02 times 10 to the 23rd atoms or molecules of a particular compound in grams. So a way to think about that is if I have a dozen baseballs, they have a mass of 8 kilograms. If I have a dozen tennis balls, they have a mass of 3 kilograms. Well, atoms are the same way. 1 mole of carbon, which is simply 6.02 times 10 to the 23rd carbon atoms, has a mass of 12.01 grams, whereas 1 mole of lithium has a mass of 6.941 grams. Note, it was the same number of baseballs and tennis balls, referred to as a group, a dozen of them, but they had different masses. This is also true for substances, except that we use moles as our quantity instead of dozens because atoms are so small. So let's review molar mass. Molar mass is the mass of 1 mole in grams, and that's equal to the numerical value of the average atomic mass. So you'll get that from your periodic table. 1 mole of carbon atoms is 12 grams of carbon atoms, according to the periodic table. 1 mole of magnesium atoms is 24 grams of magnesium, according to the periodic table. And finally, 1 mole of copper is going to be equal to 64 grams of copper, according to the periodic table. So let's try this. Find the molar mass, making sure that you're rounding to a whole number, for 1 mole of bromine. You're right if you said 1 mole of bromine was going to be 80 grams. So our conversion is 80 grams of bromine is equal to 1 mole. 1 mole of tin, yep, that's going to be 119 grams of tin. So our conversion would be 119 grams of tin equals 1 mole of tin. So let's try a problem with that. If I want to convert between moles and grams, aluminum is often used as the structure for lightweight bicycle frames. How many grams of aluminum are in 3.00 moles of aluminum? My given value is 3 moles of aluminum, and I need to end in grams of aluminum. If I look at the periodic table, what is my conversion equality for moles to grams with aluminum? That's right. 1 mole of aluminum would be equal to 27 grams of aluminum, according to the periodic table. So if I look at my mole tunnel, I'm going from moles, I'm starting with 3 moles of aluminum, and I need to get to grams of aluminum. And to do that, I'm going to be using a conversion equality that compares my molar mass to 1 mole. You just said that based on the periodic table, we're going to say 27 grams of aluminum is equal to 1 mole of aluminum. So 1 mole of aluminum is 27 grams of aluminum. I can write that 2 different ways, but when I start with my given value of 3 moles of aluminum, I'm going to want to pick the conversion equality that has grams on top, because I need moles to cancel out to give me my final answer in grams. And I get an answer of 81.0 grams of aluminum. Okay, for one final problem. I'm going to convert from atoms and molecules to grams. So my question is, how many atoms of copper are present in 35.4 grams of copper? 35.4 grams of copper is my given value, and I want to know the number of atoms. Since I'm using grams, I'm going to have to get my molar mass from the periodic table. And if I look at copper, I can see that the molar mass of copper, 1 mole of copper, is equal to 64 grams of copper. So if we look at our chart, I'm starting in grams, and I need to get over here to atoms. And I can't do that directly. I'm going to have to go from grams to moles, and then from moles to atoms. Let's set up our problem. So I'm going to be starting with 35.4 grams of copper, and then I'm going to plug in my molar mass from the periodic table, 64 grams of copper is equal to 1 mole of copper. And then I'm going to use Avogadro's number. 1 mole of copper is equal to 6.02 times 10 to the 23rd atoms of copper. You can see that as I set that up, my grams of copper canceled and my moles of copper canceled, leaving me an answer in atoms of copper. And I get an answer of 3.33 times 10 to the 23rd atoms of copper. Hopefully this helped. Please try the practice problems that go with this tutorial to master molar conversions. Thanks.